everyone, welcome to my channel. And today we are going to solve some two major problems regarding this unit. And this is the last lecture of the unit 2 kinematics. And then we will start a new topic. So before wasting any time, let's solve. Question number 25 says ball is thrown from a point P with initial velocity of u of 12 meter per second at 50 degree to the horizontal as illustrated in figure 2.38. They given us ball is going thrown from this angle 50 degree with the initial velocity of 12 meter per second. And they also draw a path of the ball, and what Q here is the maximum height point, okay, I would say, and this is the horizontal. They say a ball reaches the maximum height Q, okay, maximum height is Q over the journey, okay. Air resistance is negligible. In A, it says calculate the horizontal component of U. In the second one, the vertical component of U. So they given us a problem. Try to recall the equation which are useful here and give the answer and match your answer with my solution. We have done so many problems of this concept. Okay, try to recall the proper equation. Now the solution time, the horizontal component of u, I would say ux. So ux is equal to u cos 50. Let's suppose, understand, x, and this is the y-axis. The ball is going through this way, and the angle made with the horizontal one is 50 degree, and you can say it is the u vector, initial velocity vector. Now you have to project on the axis, and this projection is called ux, means right here ux is equal to u cos theta, and this projection is called uy, it is u sin theta. Okay, use these equations over here. Ux is horizontal component of the initial velocity. Uy says initial component of the vertical one. Okay, vertical component. So they given us a theta over here. Put the values, we know u cos 50 degree, and we will get the answer 7.71 meter per second. In second, you know u sin theta, and you will get the answer 9.19 meter per second. This is about question number A. Question number B says so that the maximum height reached by the ball is 4.3 meter. So if you so that the maximum height reached by the ball is 4.3 meter. So which equation you have to use over here? Try to recall. In this question, A is a constant, means G is acting on this. Since the G is constant, so the it is you can use easily equation of motion over here. So try to recall three equation of motion and put the values which equation is useful over here and match your solution with my solution. So at maximum height q, vertical velocity Vy is 0, as you know. We use this equation because we know V, what is the initial velocity of u, what is A over here, and we need to find S. Here, we consider only in the y direction, or you would say vertical direction. That means Vy is 0, and you have to use uy instead of using u, because you are in this particular problem, you are concerning the maximum height, okay, vertical height h, or you would say s, okay. So you have to put the value of uy, not ux, not u. Okay, and g, put the value over here, and you will get the answer 4.3 meter. So you can say that what is the height of the Q is 4.3 meter. That's we have to prove this. Okay. And the C question, determine the magnitude of the displacement of PQ. Okay, this is a P point and this is the Q point. We need to find the displacement over here. Okay, displacement, not a distance. How we can find the displacement of PQ? If we know what is the x1, y1 coordinate over here, and what is the coordinate of q2, x2, y2, and apply the distance formula, which is pq is equals to x2 minus x1 and y2 minus y square. So use this formula. I will give you a hint. This is a hint for you, but you need to find what is x2 and y2 over here. Okay. So to find the displacement vector p to q, determine the both vertical and horizontal components, as I told you, x and y of the path. So vertical distance, as you discover here, or you find 4.3, and you need time to reach q. Why? Because you need to find x of q. You don't know what is x over here. So if you want to find the x, so first you need to find the time because we need a time over here. We know the initial component of velocity of x, but we don't know the how much it takes to time to reach the point q. So for this, we use this equation. And this equation, we already know Vy is 0. At the maximum point, vertical component V is 0. Vy, we know A is minus gt, t is over here. And we get the answer of time. The ball needs to reach from P to Q. And it is time required for this also. Ux into t, it is 7.22 meter. Once you know the x and y, you can calculate this value because initial we take p as at 0, 0 coordinate. So that's why we didn't consider x1, y1 here. It is 0, 0. So it is meaningless to use over here. So it is we do directly x squared plus y squared. So after you get the answer of 8.4 meter, which is displacement vector of PQ. I hope you can clearly get the idea what is the kind of concept of the question number 25. Now, the last question. Question number 26 says a remote controlled car, toy car, moves up on a ramp. It is going some ramp and travels across a gap of the land of another ramp. They show us another ramp Q, and the first ramp is Q P, and the P at angle of theta. The car's initial speed is, I would say, 5.5 meter per second, and this dotted line shows a path of the car, or you can say a trajectory of the car, that car. And the distance between these two ramp is d over here. So what they are asking for, the car leaves ramp P with velocity of 5.5 meter per second. Okay, at angle theta. Okay, the horizontal component of the car's velocity as it leaves the car ramp is 4.6 meter. So the car lands on the top of the ramp Q. The tops of the both ramps are at the same height. Okay, are distance d apart, as we can see here. Or air resistance is negligible. Okay, so what they're asking, so that the car leaves ramp P with the vertical component of velocity 3 meter per second. Here in this question, this so U is 5.5 meter second, but the car is leaves the horizontal component means ux. They given a u, ux, and we need to show them that the uy is equal to 3 meter per second. So as you know, this is the u and this is the ux and this is the uy. So if you in order to find the resultant vector, you have to just vector addition. Since they are in the y direction and another is x direction, the angle between these two components is 90-degree, and our equation is reduced, and it will be like uy square or ux square. But we need to find uy. So try to make it the subject of this equation. You have a u and ux. So I hope you did the question, and it will give you answer is 3 meter per second. So this is about question number one. Question number two says, determine the time taken for the car to travel between the ramps. Okay, we need to find what is the time required to go from this to this point, means cover the distance d. So which equation we are going to use it? Try to recall, remember, and apply in this problem. So since the top of ramps are the same height, vertical displacement is s y 0 because the point initial point A is here, initial point, our final point B is over here. There's no height difference over here, so that's why sy is 0. Sy is 0. Okay. If you want to write sx is equal to b, means the distance between two points, horizontal points. Sy is equal to uit minus half gt square. You know g, uy, because you have find over here 3, and we need to find t over here. So it will be 0.61 second. If you want to use equation of Sx, the problem is we don't know the what is the value of d over here. Okay, so if you use this equation, there are two variables which is are unknown for us. That's why I use equation over here for sy because we know vy and sy. Why sy is 0? The height is same. We also know Vx was there, but we didn't know what is Sx, which is given. They given us D, but we don't know the value of numerical value. Okay, and so I hope you get the point. Okay, so this is question number two. Question number three says calculate the horizontal distance D between the tops of the ramps. Now we can find the what is the D over here because we know what is the time required to go this point to this point. I hope you are getting the which equation we are using. Okay. So Vx into t, we know Vx, Vt, it is 2.8 meter. So this is about question number 26. I hope you understand all the questions regarding unit 2 kinematics, and this is the all over the questions that will be maybe asked in your examination. So to practice more and more questions and try to understand, recall the equations, and put the equation accordingly. If you know all the equations, if you know all the theories, but you don't know how to use it, how to utilize the equation regarding some problems. So if you don't know practice, so if you don't know how to the apply some particular equation in particular questions, so it is important you to that solve as many as questions you can solve. So it is not about the only you can read a theory, but as well as reading a theory after you have to apply on the problems. Okay, the unit to kinematics completely. In this unit, we discuss the equation of motion, which are using only if when. A is constant, means acceleration is going to be a constant. If A is not constant, you cannot use this three equation of motion. Okay? And one more thing I want to add is projectile motion, which is very important motion. I would say 2D motion. Okay? So try to remember the theory and recall the range formula and the distance formula as well. And this is all about the unit to kinematics. So in my next video, we will start a new unit, the dynamics. So let me give you some brief introduction about the dynamics. In dynamics, we concern the cause of the motion. In kinematics, we didn't talk much about the what is the cause of the changing of velocity. So we have seen many problems. In that, we have given that u is different, initial velocity is different, final velocity is different. But uh, we say that it is about to the due to the acceleration is going on or deceleration is going on. But what is the origin of that acceleration, which is force? When the force is applied any body and body is going to be accelerate or deaccelerate, I would say, and it may changes into the velocity. So in the dynamics, we are going to study force in depth. So in order to understand the force, you need to understand first Newton's law. There are three laws which are very important to describe an emotion, whether it is under the force and if you know the what is the momentum and acceleration, you have to understand the Newton's law. Then we can also we will learn that what is the momentum. Okay, so momentum is very important when you deal with force. Okay, so force and then momentum is co-related to each other. How they are, we will discuss in our next videos, and then we will discuss collisions. So you may heard the collisions. You have seen many collisions of the cars on the road, or there are many another. Okay, so we have discussed collisions in perspective of physics. So how many types of collisions we are going to learn the physics. So there are elastics and non-elastics. So what is the difference between elastics and non-elastic collisions that we are going to discuss? And what is the conservation? You have heard the conservation of energy. You heard conservation of energy, momentum. So how it's happened? So we will discuss in the dynamics. In short, if I want to summarize the dynamics and the kinematics difference, that the kinematics in the kinematics we are dealing the effect, only effect. We didn't bother about how it is happened, how it is originating. Okay, so we didn't bother about the cause, in particular kinematics. But in the dynamics, we are going to investigate the what is cause behind it, why the velocity is changing, why the acceleration is going on, why the deceleration deceleration is happen. Okay, so comfort. So this is about the dynamics that we are going to learn, and it is very important and very easy unit, I would say, and which is also relative to your daily life. That's why I'm saying it is very easy to understand. That's because you are this unit is connecting to your daily day-to-day life. If you apply these laws in your daily life, you can easily understand the physics in easy manner. Okay, I hope you have learned or understand the kinematics. And in my next videos, we are going to going in the journey on the dynamics. So what is the going? What is the I would say what is the cause of the motion that we are going to discuss? So keep practicing, keep learning. Thank you for watching. Subscribe for more physics lectures.